today we are Group 4 and today we'll be looking at two studies on cancer risk in U.S. radiologic technologists. Both examined how occupational radiation exposure may influence on cancer outcomes using different study designs and statistical methods. We'll highlight each study's approach, key data, and why the chosen analytical methods were appropriate. So here are the overview of our studies. So for our study 1 titled The Cancer Risk in U.S. Radiologic Technologists Working with Fluoroscopically Guided Interventional Procedures. So the study population is about 90,557 U.S. radiologic technologists surveyed 1994 to 1998 and followed through 2003 to 2005 for incidence and 2008 for mortality. So it is focused on technologists who perform or assisted with fluoroscopy, and the goal was to see whether this occupational exposure increased cancer incidence or mortality. So let's now proceed to our research design. So this study used a prospective cohort design, meaning the researchers observed a large group over time without manipulating any variables. They simply recorded whether technologists ever worked with fluoroscopically guided procedures and then tracked cancer outcomes. Since the participants were followed forward in time, this design is ideal for studying risk and time to event outcomes like cancer. We have two types of data we use in our study 1, the categorical and ordinal. So this study relied primarily on categorical and ordinal data. So cancer incidence and mortality were recorded as binary outcomes, while exposure to fluoroscopic procedures and other factors were grouped into ordered categories, and some variables originally measured continuously, like age or BMI, were also categorized for analysis. Moving on to our statistical tools used. The main statistical tool we used was the Cox proportional hazards model, which is ideal for analyzing time to event outcomes. It estimates the hazard ratio to show how much higher the risk of cancer is for technologists who perform fluoroscopically guided procedures compared to those who did not, and provides 95% confidence intervals for precision. The model accounts for differences in follow-up time, handles sensor data, and allows adjustment for covariates, and also providing a clear interpretable risk estimates over time. Use the model adjustment and certification, also Schoenfeld residual test and likelihood ratio test. For model adjustment and certification, it is to improve the accuracy, and the researchers adjust the model for confounding factors such as sex, years work, smoking status, and BMI. They also stratify participants by birth cohort to control for historical differences, like older technologists having been exposed to higher radiation levels earlier in their careers. For the Schoenfeld residual test, was also used to confirm the hazard ratio remained consistent over time, which is a key assumption of Cox model. And last is the likelihood ratio test, was also used to check for interactions such as whether the effect of fluoroscopy exposure differed between men and women. So why Cox model was appropriate? The study examined cancer incidence and mortality over time among exposure versus unexposed radiologic technologies. For the data types, key variables were binary categorical and ordinal categorical BMI groups, smoking, and education. The Cox model naturally handles these variables and allows adjustment for multiple confounders in multivariable analysis. For the research question, the Cox model was ideal because the study looked at cancer outcomes over time. It directly estimates hazard ratios, showing how exposure affects the risk of developing cancer or dying. Looking at the data types, the key variables were binary and ordinal. The Cox model handles these naturally. It allows the researcher to adjust for multiple confounders like BMI, smoking, and education. Finally, considering the research design, this was a prospective cohort with follow-up times. The Cox models account for censoring and use age as the timescale and making it well suited for long-term risk and analysis. The Cox model required two main assumptions. First, the proportional hazards assumption states that the difference in risk between exposed and unexposed groups must remain constant over time. Second, the independence of censoring assumption means that participants who left study or reached the end of follow-up must not differ in underlying risk from those who continued. So let's now proceed to our next study.
Now going on to the second study, which is called Breast Cancer Mortality Among Female Radiology Technologists in the United States. This study evaluated over 69,000 women to identify whether occupational radiation exposure increased the risk of dying from breast cancer. Going on to the research design, this study used a cohort design following women from the time they were certified as radiologic technologists and recording breast cancer deaths over time. The researchers compared radiation exposure history, especially employment before 1950, to determine how risks change across decades. The types of data collected. This study relied mainly on categorical and ordinal data. Breast cancer mortality was recorded as a binary outcome, and key features such as year of first employment and years worked were organized into ordered categories. Other variables, including some originally continuous measures, were also grouped to support analysis and comparison across exposure levels. Now going on to statistical tools, the main statistical tool used was Poisson regression, which is well suited for analyzing counts of rare events. It models breast cancer deaths relative to the total person years follow-up, allowing the researchers to calculate mortality rates and relative risk based on work history. This method also enables adjustment for covariances and examination of trends across exposure categories, providing clear and interpretable risk estimates for a large cohort. Now going on to the additional statistical tools used, we found three, which is called stratification, adjustment for covariances, and test for trend. Starting off with stratification, it was used to compare similar groups by race, age, calendar year, reducing potential confounding, and ensuring that comparison are made among similar groups. Now going on to adjustment for covariances, the model also included adjustments for important breast cancer risk factors such as age at first birth, menopausal status, and family history to isolate the effect of occupational radiation exposure. Lastly, a test for trend was used to examine whether breast cancer risk increased or decreased across ordered categories, such as comparing earlier employment decades to later ones. Why Poisson regression was appropriate. For the research question, Poisson regression was appropriate because the study aimed to test whether radiation exposure increased breast cancer death rates. The model directly estimates relative risk for rate-based outcomes, which fit the research's goal. For data types, looking at the data types, the variables were mainly categorical or ordinal, such as employment period, years worked, age, and breast cancer death. Poisson regression handles these naturally, allowing comparison across categories and assessment of trends in ordered groups. Finally, considering the research design, the study used a retrospective cohort with a variable follow-up and a rare outcome. Poisson models counts over person time and adjusts for confounders, making it ideal for a large and long-term cohort analysis. Assumptions of the test. Poisson regression requires two key assumptions. The Poisson assumption states that the number of events should follow a Poisson distribution, meaning the mean and variance of a death count should be roughly equal. Next, the independent assumption requires that each participant outcome be statistically independent of others. In conclusion, these studies show the importance of matching statistical methods to the research question. Each method was chosen because it best fit the type of data and outcome being studied. This demonstrates how methodological choices directly influence the validity and interpretability and strength of the research findings.
So here are the references and thank you for listening.